Hey everybody, welcome back to Adventures in Machine Learning. I'm one of your two co-hosts, Ben Wilson, and I'm joined by my other co-host,
Michael Burke. Hi everyone.
And today we're going to be talking about a hot topic in data science machine learning. We got a guest today, Abid, and he's written a couple of articles, one in particular that we wanted to talk about, that's about this hot topic, which is AutoML. And it's something that a lot of people have been talking about for years now. It has great potential, and his article really goes over a particular implementation and also mentions some other packages that are out there and sort of why they would be used. And we're going to have a discussion today that kind of runs through what are the pros and cons of using them, what are the different flavors that are out there. And then, we'll just have fun talking about this topic that everybody is interested in these days.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So before we get started, please introduce yourself. Let everybody know what you did to get on the show and who you are and what you typically do with your days.
Hey, my name is Abid, and I basically do everything like from machine learning, data science, data analytics, and my background is quite diverse. Like I started with telecom engineering, then management, then data science, now purely into NLP side of things. And even then, I'm more into ASR, like automatic speech recognition. So I since the start of this year, I started contributing in a lot of publications, ML, machine learning, data science. And I think this is my full-time job now because I'm getting paid for writing, and there are perks too. And I like writing. I like researching new things because if you're from Kaggle background, people use very cutting-edge things. They are very creative about approaching stuff. If you see when the competition ends, you can see how people are using sometimes they don't even use machine learning to win machine learning competition. And that just makes me amazed, like how diverse that community is. And that's where I come from. Like more of my thinking are from Kaggle, participating in Kaggle competition, learning from others, checking out what's new, what's trending. Recently, there was a new AI, something like DALL-E 2, and I'm also participating in Hugging Face competition of generative AI. So that's about it. Like I really like competition side of machine learning and writing about it.
Amazing. And quick question. So you mentioned that the blog post that you did was on AutoML. Could one of you two just quickly define AutoML for those listeners that might not know what it is?
Our definitions might differ a little bit, but go ahead. You first.
So I think AutoML is just like a pipeline sequence of things that are performing from data pre-processing, augmenting data, feature engineering, then training a model, selecting a model, hyperparameter optimization, coming up with a model. That's a pure definition. It can vary because a lot of companies or a lot of packages add inference, web-based inference or API inference. Sometimes they add extra thing like optimizing. Even if you're using deep learning, they're also optimizing your layers, how many layers and how many parameters are used in that neural network.
Yeah, for my definition, I'd classify it in two different levels. And within those levels, you have different levels of complexity of implementation. But the two big groups would be black box, white box. Black box AutoML is pretty much what you said, where it can do one or many or all of the things that you said, and even some other things as well, like incorporating EDA and validation into a feature set, doing feature selection based on an iterative process, which that can get really expensive and really time consuming. But when you're talking about black box, you have no visibility into what is going on there. It's self-optimizing. And what you get on the output is generally a report, could be statistical validation of cross-validation of saying, hey, on a holdout data set, here's how this black box performed. And here's some explainability. In the paper that you were talking about, you were mentioning AutoXGB, and XGBoost could give you feature importances, which your mileage may vary on how valuable those are and how much that correlation people mistakenly understand as causation. But you can get some sort of report out of it, but you can't really manipulate a black box model. So the APIs for those are usually, here's my data set, here's some config that I want to constrain this problem by, and just do the magic for me. You can be looking at some that are 2 or 3 lines of code to do something that if you're doing it manually utilizing open source APIs, it could be hundreds, if not thousands of lines of code. And then, or it could be a little bit more mid-level where you're defining the basic structure of a pipeline for that black box. But at the end of the day, you're not really able to access the code. White box, on the other hand, is exposing code. And before we started recording, you were talking about code gen, something that you're saying, hey, Salesforce is this new cool thing. It's using NLP and generative deep learning to generate code. And then some other companies, such as the one that I work for, Databricks, has their own AutoML solution that will use code templates to generate through Jinja. And it'll figure out what the optimal setup is, but then it'll write the code for you, which then you can go and manipulate yourself or add to it or remove certain steps because you understand the problem space. So that's kind of how I would separate the two fields of AutoML.
And where does the pipeline start? You mentioned that there's feature selection involved potentially. So it probably doesn't serve the model. It probably doesn't build the ETL pipeline. But where do most ML or AutoML packages start and stop, would you say?
Data processing, simple data processing, finding out missing values, sometimes even like augmenting data. If the data set is deployed, try to find out optimal way to like categorize, convert it into using label, like converting into numerical values. There are a lot of things. It's the basic thing is cleaning up your data. Some AutoML do a really good job in cleaning up your data and preparing it for pre-processing and data augmentation, and then training. And then there's a model selection, because initial training just tell you the feature importance. Some AutoML also select the features, and then they train it later on it. But most of the time, what they do, they select a model, and then if you type more time, because it's a time waste. If you don't give a more time for model to run, for AutoML to run, it will skip the hyperparameter optimization and it will just run on the basic, the best model it come up with, and just give you the final thing, a model. Like the main thing, the output is a model, the input is the data, and you can use that model to predict anything, but according to your business problem.
So if we're starting on the feature imputation stage, where we're like, hey, let's say we have 10 features. 3 of these features are categorical and they're nominally indexed to, let's say, day of week on one of the features. And this nominal indexing starts from 0 to 6, 0 being Sunday, Monday being 1. And then there's a problem with the data. And sometimes we can't get a date timestamp associated with that training data. If we're going to have a selection process for AutoML that's going to impute by sort of open source pipeline standard defaults, where it's going to say, well, missing values are 0, what do we have to do with an AutoML package? Or how does that increase the complexity of that, depending on what model we select for that imputation, to make sure that we're not polluting or contaminating our feature set when we make a selection?
I think Light AutoML have this feature called date. you can just give a column as a date, as select as a date, and it will create its own features like week of the day, year, and you can also tell, is it a year or is it a day or is it a week? And it will impute and it will add value according to that. And you can also select what type of imputation you want to use, what type of filling you want to use. Do you want to use most common day use in that day? Let's suppose if it's every Monday or if it's every Friday, it will automatically choose that day. But you're right about sometimes it's a hit and miss. Sometimes your data is quite complex that even AutoML doesn't even understand what it have to do. Even if you give it's a date, it's a categorical, it's a numerical, and it's a float, whatever you're assigning your features. And even if you even go into the more detail, tell what imputation you should use, what type of like feature engineering you should use. Even after that, it fails because your data is complex. You need to make sure your data is ready for the model to work sometimes. And that's in all production, in all machine learning production level. The most time is spent on cleaning up, making sure your data is ready for your model. Yeah.
Yeah, this is one of the reasons why that use case is a pretty simple one. When you think about it, it's like, oh, well, I just need to make sure that I have some sort of rule-based system in there that says, hey, if this is missing and it's of this type, I need to select some index value that the model will know based on what its type is. If it's tree-based models, I'm going to give it some index that's definitely different than any value that's in there. So it knows this is sort of unknown data. But then if it's a linear model, you have to have different decision for imputation. Maybe it is the mean, maybe it is the most frequent. There's a lot of considerations to go there. But as you said, the only way to know whether this is going to work is to build a model and then see the results on holdout validation. And this is one of the reasons why some people who don't have Scrooge McDuck money laying around to run all the tests in the world through AutoML, that's just n number of experiments that you now have to take times m for, your feature vector, consideration, where you're saying, all right, if I have 100 features, I don't know what of those features are going to be problematic, are going to be, auto-correlated with one another, or it's going to be correlated to a target in a way that I don't want it to be. So I need to drop this feature. That iterative process, in order to know if your model's good, it still has to tune hyperparameters, which that's a whole big chained process as well. Yeah, you can do asynchronous operations, you can create multi-processing pools, thread pools, or you can run it on Apache Spark and do distributed hyperparameter tuning. But at the end of the day, it's still an iterative process, which gets really expensive. So what are your thoughts on that where it becomes turtles all the way down when you're talking about complexity of building an AutoML solution, where you say, where do we cut off and say, okay, we're just going to push this on the user to figure out. We're not going to try to solve this with the toolkit.
I think you're right about there are some pros and there are some cons about AutoML in general, like expensive compute, because if you want best result, you have to run it for hours. It won't produce best result if you're running for 20 minutes, and it will skip all those tests and it will give you very vanilla model, and it will have very low metric accuracy for the simplicity. So I think you are right. We can use third-party tools or other tools integrated with AutoML, but most AutoML doesn't use these kind of tools. And you can adjust use multi-threading, even use GPU. Even Optuna have some kind of thing. You can use it for GPU. You can reduce your compute time, but eventually you are using compute. It is expensive in terms of if you are training it on cloud based, it is expensive, and it is time consuming too. Sometimes you're running an experiment and you really don't know what the result will be in the end. It's going to ensemble multiple models, what the final result will be. You just have to wait certain amount of time to get the result, and if the result is not according to your baseline, you just wasted another 8 hours training something that is not even desirable for companies. And there are drawbacks and a lot of thought put in. And that's why there's a pushback from like expert level, like for the company, like for multi-dollar companies who doesn't want to use it. There is a reason, because it's just not like effective method to approach any machine learning problem. So that's what I agree. But there are a lot of like 80% of people who doesn't want to go into the detail. They prefer the AutoML. So there are pros and cons about it. And yeah, this is one of the con, and there are a lot of con in AutoML, not just this one.
I don't know. I could tell you from my perspective of being a practitioner for years, I was using AutoML when I'd work on projects. Some of the open source stuff that's out there have tried out proprietary things because of that fast response time, where I'm like, hey, I need to prove this idea out. I don't even know which library to use. Do I want to write, 16 different implementations of proof of concept for model implementation and then wrap that in HyperOpt or Optuna so that I can tell, like, hey, am I even in the right ballpark? I'm not going to run a proof of concept for 12 hours of hyperparameter tuning, but I'm going to run it for a half an hour. And I'm going to say, can I even get solid hyperparameter results? I'm going to look at the history of the hyperparameter tuning. I'm going to extract from Optuna or HyperOpt. What was the training history? Because that's going to tell me, how stable is this model? Does it respond well to small adjustments in hyperparameters? Because if it doesn't, then it's an unstable model and it's probably going to blow up in production. But if it's pretty robust and you can move things around 5-10% on parameter tuning, and you can do different cross-validation selections from subsets of that training data, I know it's relatively robust and it's probably a safer bet for production. But once I have those answers and that data, and hopefully, the white box stuff is much more appealing to me because it generates code for me. And then I can look and see what decisions were made. Even black box stuff, you can still look at the reports. And usually there's some sort of text report readout and standard out that says, hey, we detected that these 7 fields should be dropped from the feature engineering because they're autocorrelated with one another. And it's causing it. There's going to be some issue with these in a production model. And that's super useful. It's better than having to do correlation analysis manually. So I think it's great. But then I take that and then start working on code from scratch, properly constructed and architected code that's testable, custom, manipulations that are going to be done in the feature engineering stage to make sure that I can send sample data to that method or to that function, and I can validate that it's doing what I expect it to do. But when you say that the 80% of people, I would group myself into that. I'm not some like data science purist of that 20%. It's like, I will never touch these tools. I think that's ridiculous when people behave like that. But within that 80%, you lumped in, I think, 2 big groups of people. One is serious practitioners who are having to maintain stuff in production. And then there's also the people that are trying to learn. Do you have any thoughts on how good it is for somebody to use that as a stepping stone to get exposure to this world of data science and machine learning?
I don't think people should learn AutoML. Just be clear. It's just like you're teaching a student nothing. You're not even teaching a basic. What AutoML is 3 lines of code. You're just teaching them to write a 3 line of code and then see the magic. There's no magic. I'm just being honest about machine learning. Machine learning is not magic. It's just an algorithm. It's a math. Just go back to the basic, learn what's really going on. Yeah, there is hype around it. And sometimes it's just a noise. And a lot of people get distracted. Oh, this is very easy. And they even post on LinkedIn, Twitter, I made this. I made facial recognition. I made text. I can talk to a bot. My bot is so good. I'm training my bot. And I just wonder what they're learning. They're learning nothing. They're just copy pasting and using these tools to get, even in competition, you will see like top 20 people who have used AutoML to get like in top 20. They have learned nothing. They have learned one thing, how to manipulate something. And in the production, in the real world, this is going to backfire, and the employer wants value. They don't want how you come up with the solution. They want value.
Yep.
Will it work? Does it solve the business problem? Why what if I increase the throughput? Will it crash? Is it compatible with the other integration that we are going to use? Is it compatible with the APIs? Is it Kubernetes? Blah, blah. There's so many lines of things that they will ask, and the person will say, I just use light AutoML, and that's it. And that's it. That's the end of it. So if you're learning, if someone out there who is learning machine learning, who is learning these, who is like navigating these rules, try to start with very basic. Learn how linear regression is made. Even if you want to use NumPy to create your own linear, that will open your mind to a new world. Then you can, these shortcuts are for the profession. I'll just say these AutoML should be part of profession. Who doesn't have time? And let's say, your manager say, I need to submit a report to the stakeholders. You have to ask, please give me something. Use AutoML. Give them something. Don't use it to like teach. Don't use it in the final product that you are going to use. Don't use it anywhere else. If there's a time constraint, and if you don't have time to code lines, use the AutoML and use the solution to give an idea, to give initial idea to get funding. If you're a startup, you can use it to get initial idea what you are going to do, what you are going to add. So that's the middle part. It's not a beginner. It's just the middle part connecting two worlds. So yeah, that's my take.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
I'm glad to hear that. I think we're on the same page with that theory. I have nothing to add to that. And yeah, what are your thoughts, Michael?
Yeah, I have one thing to add to that. I completely agree. I think that it's a tool in the toolkit, and everybody has X amount of hours each day, right? And there are a bunch of different ways you can tackle things. Well, if you're building a machine learning model, you're definitely not going to be writing it in binary. At least I hope not. You're probably using some higher level programming language with APIs and pre-written code. That is not sacrilegious or against the spirit of creating stuff from scratch. You're just using good tools. And I think it's the same thing with here, that if the AutoML solution does provide robust starting places, then why not use it for every project? The one caveat that I want to mention, at least that I was thinking about through this conversation, is that often you get a lot of insights by doing EDA and by struggling through trying a bunch of different stuff. If you already know your data, great, and just slap a model on it. But as someone who likes to take the old school approach where you plot everything and you like look at distributions, you are often skipping that step with AutoML and sometimes get a false sense of confidence about your data when really there's a lot of weird stuff going on behind the scenes that you would have picked up had you used a more, whatever the word is, basic, slow approach. So just one thought there. Classic. Yes. That's traditional. Yes.
And that's something that is separated by another categorization of AutoML from my exposure, which is open source versus proprietary. And open source toolkits, speaking from a company who does an awful lot of open source work, we try to provide functionality that's going to have parity with what we offer as a paid service. But that doesn't mean we're going to offer all of the ease of use to open source. It's going to be more, here's the APIs. They're the same in our product as they are in this open source package. But when you get into our platform and start using it, you'll notice that things are just sort of easier to use. There's a little bit more fluidity with it. Maybe the performance is thousands of % better. And you see the same thing with AutoML. And I think from an outsider looking in to a company that does that, I think some people who are huge fans of just pure open source everything, they get kind of upset about that. And I've talked to a couple of people that have had that viewpoint, like, well, why wouldn't you submit this huge feature, this performance feature into open source? I'm like, well, then we wouldn't be a company because nobody would pay us for that. So you see the same thing with companies that are centered around AutoML as well. Not all of them offer open source implementations, but some of them do. And the experience is very different between their paid service and the open source one. Like H2O is a great example. Their tool is pretty cool. I'm a fan of it. And the open source implementation of it, yeah, you got some things that you can do with it. But when you are like attached to their service, it's very different. Like they will generate plots and graphs and reports, and it's more automated in that sense where it's explaining your data for you. But to do that with the open source toolkit takes a lot of work, or you need to use outside packages. And before we were recording, we were talking also about like Data Robot has an AutoML solution that's very sophisticated, and their dashboards for that EDA process are essentially the standard. And the only place that I've seen that level of explainability of a feature set is in SAS, which is most certainly not open source and probably never, ever will be. But that is the gold standard or the platinum standard. So yeah, Michael, I agree with like that, the need for doing that. And it's most AutoML toolkits don't do all of that because at least they're not going to do it for free just because of the complexity involved. You talk about auto EDA and making decisions to go into features. You're never going to see that in open source. You're not going to see one that actually works well or that runs well. And it's just pure economics. How many top level engineers need to devote how many years of their life to building that thing? Who's going to pay their salary? You're not going to get donations from GitHub, from people being like, yeah, I love this. Here's $50,000 for, a quarter of your team's time. Nobody does that. You might get $20 a year from somebody like, hey, great job on this toolkit. Love it. So yeah, that's why you're never going to really see that.
I think I will disagree with you on open source getting paid. A lot of companies who are open source get paid, like from licensing and from other means, like from donation, from, there are a lot of societies out there who supports open source and they want it to, like, even GitHub have a sponsor. You can get a lot of sponsor. Now they have expanded their sponsor feature to add any like coffee, buy me a coffee or something. You can add all those links. If you have even Bitcoin, people are getting paid. It's not just like limited, but I do agree. Like majority of companies don't make profit, but they can make a living out of open source, but they don't make profit. So sometimes they have a different like business model of generating revenue. You can see a lot of companies who are into open source, they do earn profit, but sometimes they don't disclose. I think it's maybe they are selling the licensing to the other B2B or business to business. And other part about creating EDA, you talked about creating auto EDA. I think there are a lot of open source auto EDA that sometimes amaze me, like partner profiling. There are a lot of, I even wrote a whole blog on it, like to get like all the auto EDAs. You can even check your data. They will even tell you which feature is buggy and maybe you need to make sure it have missing values or it have some strange value. They will even check the anomalies. Let's suppose it's a categorical, it should be a categorical, but it has some numerical. Even it will tell you outliners. So there are tools, but these are separate tools. They are not part of AutoML ecosystem. So you can have like auto. I think there are a lot of auto. It's just not like even there are auto ETL too. There are auto pipelining, auto automation tools that makes it easy. Auto just mean making things easy. You are repeating some task again and again, even in machine learning, even in deploying your model. Those tasks are quite like frustrating for developer or for machine learning engineer. So these tools just automate these tasks so that the engineer doesn't have to redo it again. Most of the companies, they don't even show that they are using AutoML, but they have created their own AutoML for their own use, for their own pipelines, for data pipelines, machine learning pipelines. they are using some sort of their own version of AutoML, but it's very restricted to their own use case instead of like general use case. So I think AutoML for future can be very use case based. It should not be a general based. Let's suppose if a company wants to automate, wants to like active learning, if they are using active learning, they don't want to go and check when the new data comes, the performance drop. They want the best performance possible, even if the new data is dirty. The pipeline should make sure that data is clean. It is not violating any rules. It is data is not drifting. It should match all those rules and deliver. That's called automation. It's not something magical. It's just making sure these steps are automated and easy for developers to use.
Yeah, one counterpoint to your open source funding.
Okay.
So if you look at it at, say, the top 500 GitHub projects that are out there, if you look at the signatures of the people that commit to that, I guarantee every single one of them works for a major company.
Yes.
If you look at the project that I work on right now, MLflow, now we have employees at Databricks who contribute about 98% of the code to that. We're full-time and paid employees. So the concept, what I was trying to bring up before is if you're doing an open source project and you don't have a company paying for your time or allowing you to contribute to open source, look at something that's not attached to a company. I mean, MLflow is typically, technically created by Databricks, but it is an Apache project that we have hundreds of committers that don't work at Databricks. They all work for companies. They're not living in their parents' basement and hoping that somebody's going to donate money to them because of their commits. It just doesn't happen. We don't pay the people to do that because it's an open source project. But look at something like sklearn, which is probably one of the most imported Python packages in the data science world. If not, well, maybe pandas and NumPy are. But there's no company that owns those. It's just a collection of tons of people from different companies that they're getting paid by their companies. Their company is allowed to use that open source software. That's how that economic model works. But all of the big packages, that's the point that I was trying to make, is if something is made into open source and it's sponsored by a company, they have to make money off that somehow. So they have to separate that out and say, we're going to give bare bones functionality. And that's why that EDA matching it into an AutoML project, there's proprietary systems that offer that. And they're pretty sophisticated, but it takes a lot of time and effort to merge those two together correctly.
Yeah.
It's a large undertaking.
I just want to add to your point. I think sometimes governments are paying for working on open source. If you see DuckDB, it's a tabular SQL-based database. So you can run on CVS or any Parquet or any database data file that you're using. And they are really good. They are very fast. And they are supported by Netherlands government. And they are getting paid from that. Like I just told you, no one who is doing open source. They are not like dying of hunger. They're not unemployed. They are getting some revenue from somewhere, not just from companies or not supported by some companies even support like people. We are paying you, go work on open source project, go contribute. Some even say like there's a TensorFlow, maybe add this feature. We need that feature. Just contribute. Even I work with like a lot of Hugging Face team, and when they have some new feature and they really like the library, they just contribute and they just create a pull request. And they just keep pinging that maintainer, please accept this. We need to push this into our new development. Because it's a hierarchy. They are dependent on these things. TensorFlow or PyTorch, scikit-learn. Mm-hmm. These companies are dependent on these packages. So they are also making sure that they keep getting updated. So they keep getting improved with the time. So this is how these developments are working. And people are getting paid to contribute. Like if I can tell you the name of Omar, he works in a Hugging Face. He just pushed a request to improve the new version of what is called Streamlit so that it supports their own ecosystem of spaces. So he have done all the work. He even pushed create a pull request, and he even contacted one of the maintainer, please accept this so that it doesn't break on their end. So it's just dependency. These people, these companies, companies who are making profit, they need these open source projects. So that's how these open source projects are getting revenue or getting some kind of hype or some kind of support. Even I have seen a lot of people getting hired who have worked on open source. They get hired like this if they have like pushed really good creative, really good pull request, and they like that feature, and it's quite new and a very interactive feature that can improve their performance by a lot. They even hire, okay, come, we are hiring you. Like it's not the dead end that you started with, but it's a really promising thing for anyone who is contributing, and they are earning somewhere. Even if they are not earning, they are having they are building their brand. That person is getting recognized. If that repository got like 2K or 3K, someone will look at the recent contributor and see, oh, he contributed this. He will click on the profile. I do that. I don't know about other people, but I do that. Oh, this feature is quite new. It is very, how did he come up with? I'll even sometimes contact him. How did you resolve this ASR problem? How did you integrate language model into the ASR model, or how you're improving your model by just speech processing? So people are there and they will help. And if I like his work, why not hire him? Because he knows better than me.
Yeah, I mean, that's why a lot of companies sponsor open source contributors from external. You don't have to open up your repo, even though it's open source, to accept external contributors. That's why we do it. To build a community, build notoriety around the functionality of that toolkit or these projects that we do. But we've hired people who were contributors to MLflow, to Databricks. Like one of the best engineers on the open source MLflow team is somebody who was just a prolific contributor, and he's now a team member. And the guy is amazing. He was on the show a little while ago, Michael, Haru.
Yep.
Yeah, he's a brilliant developer. And yeah, I agree that that's one way to do that. The only point I was making is if you're getting paid to contribute to open source, you're an employee of somebody's or you're a contractor. So you need to get money from somewhere. And there's no guarantee that that if you're like, okay, I'm quitting my job, I'm going to create this open source project, that's all I'm going to work on full time. Because if you're supporting something that has a lot of people using it, there's a lot of bug fixes, a lot of feature improvements. Look at an issues board of anything where you have the level of what, MLflow, we were just checking the numbers yesterday before the next release. It's millions of downloads a week. And you have that many downloads and that many people using it. Yeah, when things are broken, they let you know very quickly, like exceptionally quickly, and you have to fix it. So if it's just a small team of people putting in all that time and effort, somebody's paying the bill.
I think if people donate, these tech institutes, some even billionaires, they donate for any certain reason. They donate money to these organizations like Apache or like they donate. That's how the ecosystem works. Even the Signal, or there are a lot of applications out there who are running on donation. Like it's just not, and the donations are enough. They are not profiting from it, but it's paying their bill. It's paying, like, even if you're a small, there was let me just give you an example of GitHub. There was like to add, in your GitHub profile, Markdown, you can add features into your stats, very interactive stat. And if you go to his profile, he have like GitHub sponsor, and you will see a lot of people sponsoring him, not just one. There are a lot of people sponsoring him. He didn't do anything. He used like JavaScript or TypeScript to create this very simple. It's not complex, but it's very people are using it, and a lot of people are using this tool, and a lot of people are supporting it. It's not that dead end. I think even if you're not supported by a company, you can get lucky or get hired, get donated, or even get sponsored, or even like research. You can come up with the research. And I have seen a lot of people like in my community, they start a startup. Like two of them, oh, you are really good at this. I'm really good at this. Let's combine this and start a new company, start a startup, and let's see where we go. And there are opportunities. Not, I just want to say, startup is not a dead end. is people are somehow getting paid. They are getting recognized. They are building their brand. Even if you have like 3K followers on LinkedIn, you are some kind of celebrity, and people are listening to you. They're liking you. And sometimes small company approach you. Can you promote this? They are getting paid. There is some ecosystem around it, and that's how this whole thing works. Your work is not wasted in anywhere.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Oh, couldn't agree more. I think the open source community just needs more people contributing to it. It's just going to be challenging to find the cutting edge stuff that does all the things that somebody's going to give away for free. That was my point.
I think even if it's an open source project, I'm just going to be very controversial. Like, even if it's an open source project, OpenAI will make it monetized. It will monetize it. And there have been GPT-2 was a model. It was open source. Everyone can use it. When they saw the potential that it can bring, GPT-3 was not open source. And after that, whole company went from being open source, being community for community, to being very close and very profit oriented. And they have created a lot of products. And even recently, DALL-E 2, it's really good product. There are some similar products, but they don't have a good PR or marketing team, and they don't have that much funding to promote that. Because if you go to Hugging Face Spaces, you will find similar product, but it's not that polished. They have just polished it, marketed, asked influencer to just say wow, 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 and just share your stuff, and we'll give you early access, stuff like that. So they have this kind of, but I do think open source can compete, but they don't have the funding to do that. I'm not sure about cutting edge, because there are cutting edge, like even after GPT-3, people said we cannot replicate this, but there have been GPT-Neo, even there is next version of GPT-Neo or other, these large transfer model that people are still using, but they don't have that, marketing power, that kind of cash to promote this, even if they are competing on the same level. So
yeah, and sometimes that marketing aspect is what makes or breaks a project from getting into the zeitgeist of ML engineering worldwide. On that note, this has been a very interesting topic that we kind of drifted into, the philosophy of open source and what the benefits are. I had a great time. Thanks for coming on.
Yeah.
And in closing, where can people reach out and find you and potentially continue this discussion with you?
I think they can reach out to me on LinkedIn. One Abid Ali, like numerical one, Abid Ali Awan, my name. And even on Twitter, the same, numerical one, Abid Ali Awan. Yeah, that's it.
All right. Sounds good. So that pretty much concludes our episode. And if you want to learn more, check out the notes that are attached to this podcast episode. You'll get some contact information from our guests and that Twitter handle and LinkedIn profile. So until next time, thank you very much. I've been Ben Wilson, joined by
Michael Burke.
Abid Ali.
And take it easy, everybody.
Thanks, everyone.
Bye, guys.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.